Hi everyone. So welcome to Design and Analysis web series. I have posted so many concepts related to design and analysis algorithm like recursive and non-recursive algorithm, greedy algorithm, dynamic and so on. So if you want to know more about this, kindly subscribe and follow. Hi everyone. So welcome back to the design and analysis of algorithm. So today we are going to see one of the sorting, merge sorting. So we have so many sorting under the divide and conquer. This is the second example, merge sort. So consider a list of element 3, 1, 11, 7, 5, 9, 2, 6. This is an unsorted list of elements. So we are going to sort this unsorted list using the merge sort. So what is the first step? We need to divide the given subproblem into two subproblem. So either you can find the n by 2 or n plus 1 by 2 to find the mid element. So what will be the mid element? Either 3 or 4. So this is an unsorted list. We will take it as a first case scenario. So in this case, the first set of mid element is 0 to n. So we will write the 0, 1, 2, 3, 4, 5, 6, 7. So 8, n is equal to 8 elements. So either you can find it as 8 by 2 or 8 plus 1 by 2. So let us consider the mid element as 4. So therefore up to mid element the set is divided into one sub problem. The other set 9 to 6 is divided into the second sub problem. So likewise the given set is divided into two sub problem. Okay, two divide and conquer. According to the divide and conquer concept, the problem is divided into two sub problem. Similarly, we need to start the process from the beginning for the first sub problem. So, find the mid element. So, up to 11, the set is divided into one set. 7 and 5 further is divided into the another subset. So, until the element becomes single, we need to divide the set of element into further. Okay, so now 3, 1, 11. So, here the mid element is 1. Therefore, the element is divided up to 1. 3, 1 is one of the set and 11 is the another set. Similarly, 3 is divided into 3 and 1 as a single set. So, the same process should be followed for all the subproblem until they divide into a individual or single element. So, this is the second subproblem. 9 and 2 is divided into one set. 6 is divided into another set. Likewise, these two 9 and 2 are divided into a single element. So, after completing this process, we need to merge the element. So, how we need to merge the element? While merging the element, we need to sort them. For example, here 3, 1 and 1 we are going to merge and therefore the element is sorted in the order 1, 3. So, 1, 3 is the sorted list. So, likewise, we need to merge all in the same order. So, the 11 will be again merged with 1 and 3 only. So, not with the 7 and 11. So, 1, 3 and 11. So, these two subproblems are merged together. Again, the next subproblem is further merged with the sorted order 5, 7. Similarly, 2, 9. So, these two subproblem are also sorted in the same manner. Likewise, until we get a single set of element with the sorted order, we need to process the same manner. Okay, therefore, at last we are getting 1, 2, 3, 5, 7, 9 and 11. So, this is the answer where we are getting in the sorted. So, here in this first case, we have taken the list of element in an unsorted manner. So, unsorted manner we have taken the list. So, the case may differ. Suppose if the case is given in a sorted order, we shall take the second case. If the already, okay, when they are issuing in the problem is, so if the list of element is in the sorted order, so here it is in increasing order, 10, 20, 30, 40 is in increasing order. So, if it is in the increasing order also, we are dividing the set into 2 by finding the mid element. So the same process, we are doing the same process. So what we are trying to say is either it is the worst case, best case or the average case, we are following the same scenario. See, again we can take the another case scenario which is given in the descending order. So the list of element is given in the descending order, 100. So 100, 50 and 20, 10. Okay, so this is in the descending order. So the previous list which we have taken in the ascending order. So this is the case scenario, third case. So this is ascending order. So this is the third case. So though it is given in the descending order also, we are going to follow the same method by finding the mid element. So up to the mid element, the set is divided into one subproblem and the other subproblem is divided into a single element 10. So n by 2, n by 4, n by 8. So likewise we are going to divide the set into 2. So which comes under the divide and conquer concept. So 20, 10. So either we can find the mid element with n by 2 or n plus 1 by 2. So further this element is divided into a single element. The set is divided into further and further. So after that what we will be doing, we will merge all the element in a shorted manner. So the same scenario, the same method, divide and conquer method is followed for the various case scenario. Whether the element is in ascending order or descending order or unsorted order. So whereas in the quick sort we will not follow the same pattern. For the best case we will follow some other pattern. The set will not be divided into two subproblem in quick sort. Whereas in merge sort, if it is a worst case also, we are dividing the set into 2. Therefore, t n by 2. So t of n by 2, how many set? 2. And the 1 is nothing but to merge the element. So 2 set of element. So 2 subset. We are dividing the divide and conquer means what is the meaning? We are dividing the subproblem into 2 subproblem. So 2 t of n by 2 plus 1. The 1 is nothing but we are merging in the bottom up approach. We are merging the set of element in a shorted manner. So that particular constant time is taken in the value as 1. So this is the merge. So C merge of n. Okay. So now we can solve this particular recurrence relations with the substitution method or the master theorem. So better we can take the master theorem. A is equal to 2, B is equal to 2, D is equal to 0. Why? Because there is no function available in the part of f of n. Only 1 is available. Therefore, that particular function is taken as d is equal to 0. So, when we apply this in the 3 case scenario, either it is less than or greater than or equal to, we will get the time complexity of n log n. So, this is the time complexity for all the cases. Either it is in ascending order or descending order or shorted order. We will get the time complexity as big O of n log n. Okay. Thank you.